Hey everybody, this is video 29. This is the second part of the double replacement reactions. These are acid-base reactions. Not all of these are going to be true double replacement, but I think you'll get the drift. Before we just start talking about acids reacting with bases, we need to have a little better understanding of what acids and bases are. Acids are compounds that produce hydrogen ions when they're in aqueous solution. Bases are substances that produce hydroxide ions in aqueous solution. Notice that we got both reactants are in aqueous solution, and so in the future we've got NIEs coming up. But the thing I want you to focus on here is associate the hydrogen ions with acids, associate the hydroxide ions with bases. So let's talk about acids first. So how do acids put hydrogen ions into solution? Well, they simply ionize in water. And notice I use the word ionize here instead of dissociate because it's a covalent bond that exists between the hydrogen and the chlorine atom. And it's the end product. We talked about this a long time ago. We were talking about electrolytes, but the end product is the same as when it dissociates. You get ions. And so acids put hydrogen ions in a solution by simply coming apart. Electron is completely transferred, and we get a hydrogen ion and a chloride ion, in this case with hydrochloric acid. Down here we have acetic acid, and therefore we get a hydrogen ion and the acetate ion. So essentially, the most important thing you need to recognize is we get the hydrogen ion, and then we just get the anion, what's left over after the hydrogen is lost. But here's the deal. There are strong acids and there are weak acids. And the strong and weak refer to electrolytes. Do you remember talking about strong and weak electrolytes? So strong electrolytes, they ionize 100%. So for example, if we had HCl, which is a strong acid, in this beaker, just like if we had NaCl in there, we have no complete molecules. All we have are hydrogen and chloride ions floating around in solution. So for every HCl that's in there, every one of them ionizes. Weak acids, like over here, let's say that we have acetic acid, they ionize less than 100%. So some of them do dissociate, and so we do have hydrogen ions and acetate ions floating around, but a bunch of them stay together in the molecular form. Okay, so they ionize way less than 100%, most of them. Now, they do produce some hydrogen ions, so that makes them acids, but they don't always do a very good job of it. So here are the 6 strong acids. You need to know these. 3 of them are binary acids: hydrochloric, hydrobromic, hydroiodic. 3 of them are oxyacids. They have polyatomic ions. This one is nitric acid. This one is perchloric, because that's the perchlorate ion, and remember 8 goes to ic. And this one is sulfuric. These are the 6 strong acids. Every other acid is weak. Nitrous acid, weak. Hydrofluoric acid, weak. The one we were just looking at, acetic acid, weak. So we just saw how acids put hydrogen ions into solution pretty much the same way, whether they're weak or strong acids. Strong acids just do a better job of it. But with bases, they put hydroxide ions into solution a little bit differently depending on if you got a strong base or a weak base. So let's talk about strong bases first. Strong bases are the soluble metal hydroxides. So that means we're talking about the group 1 metals with the hydroxide on. I listed 3 of them here, but there's a couple more. Sodium hydroxide, lithium hydroxide, potassium hydroxide, those are all soluble. They've got alkali metals with them. So that's how they produce hydroxide ions. Some of the group 2 Metal hydroxides are also soluble, so barium and calcium and strontium hydroxide, those are also strong bases. So you're looking for some kind of metal with a hydroxide on for a strong base. And so like we just mentioned, strong bases produce hydroxide ions by simply dissociating, and this is a true dissociation because it's an ionic compound. See the metal, the sodium. So we don't call it ionization, we call it dissociation. That's just a little kind of picky point, but that's the way it goes. So notice it ionizes 100%. So for every sodium hydroxide that's in solution, every one of them dissociates into sodium ions and hydroxide ions. It's a strong electrolyte. Weak bases are a little bit funky. There's a few different, there's a whole bunch of different kinds of weak bases, but the most common weak base are derivatives of ammonia. If you remember, this is ammonia, okay? And so derivatives of ammonia looks like this. It's nitrogen bonded covalently to 3 hydrogens. Everything here is non-metals. We'll talk about what those dots mean later. But this one would look like this. It's also got N and H, but it also has a CH3. The thing that you need to focus on is you're looking for some kind of form of ammonia, like an NH2, or sometimes it's just NH. But you're looking for some derivative of ammonia, and those are the most typical weak bases. There's other types, but those are the ones that we're going to look at. Now, the way that weak bases produce hydroxide ions is not as straightforward as how the other ones work, but basically the weak base, in this case ammonia, takes a hydrogen from the water and forms the ammonium ion, and then what's left is the hydroxide ion. So you see it puts the hydroxide ion in solution, just not directly. This reaction has to occur. So here's another weak base, methylamine. It takes on a hydrogen from water. It produces this ion. Notice that the charges here are positive because they're gaining a positive hydrogen ion, and then what's left after this thing loses the hydrogen is the hydroxide. Now they're weak bases because they don't do a great job of this. Ammonia, like in solution, there's still a lot of ammonia molecules in addition to hydroxide ions and NH4 pluses, and so there's quite a few ammonias, so it's not like it's 100%. Alright, so here's kind of the summary. Here's your 6 strong acids. Here's a few examples of some weak acids, but remember, if it's not one of these, it's weak, so I just listed a few of them. Here's your strong bases. Notice it's mainly the group 1 and group 2 metal hydroxides, and then all these weak bases are ammonia derivatives. By the way, this type of weak base is called an amine. Like you may have heard amine, like dopamine. Epinephrine actually is a weak base. Here's a little summary of the whole thing. Okay, now that we know what acids and bases are, we're going to look at 3 different acid-base reactions. Strong acid, strong bases, strong acid, weak bases, weak acid, strong bases. So I know you're probably wondering, why aren't we going to talk about weak acid, weak bases? That's a little more involved. That's a topic that's covered in AP chemistry, so we're going to stick with these 3. They're pretty uncomplicated, I think you'll find. So we'll talk about strong acids and strong bases reacting first. So here's an example. There's hydrochloric acid, strong acid. There's your strong base, sodium hydroxide. Since these ionize 100%, then really the hydrochloric acid exists like that. These are all in solution, don't forget. Sodium hydroxide really exists like this. So what happens is the hydrogen ion bonds with the hydroxide to form water. And then what's left is, guess what, an aqueous solution, sodium, I should say chloride. Notice the spectators. The sodium ion doesn't change, the chloride ion doesn't change. So here's the deal. The NIE for strong acids and strong bases, no matter what the strong acid, strong base, is always written like this. Whatever's with the hydrogen ion and whatever's with the hydroxide ions ends up being spectators, and you get hydrogen ion plus the hydroxide ion going to water every time for a strong acid, strong base. Alright, what if we're talking about a strong acid, weak base? Well, if we're talking about a strong acid, weak base, here's an example. There's your strong acid. And so really in solution, all this is in solution. That's going to really appear like the hydrogen ion and the chloride ion. This is not ionic, it's molecular. So in water, it's going to stay pretty much like NH3. This is, everything here is an aqueous solution. This is soluble. It's got an ammonium ion. Remember, everything with ammonium is soluble. So really in water, it's going to exist like this. And so you can see the spectators here are the chloride ions. They go away, and what we're left with is this. And so, for example, so that's the NIE for a strong acid and a weak base. So H plus, here's another example. Let's say we got methylamine. Okay, CH3NH2. The product is going to be CH3NH3 plus. Notice that the product here is going to be positively charged because this thing is neutral and it's gaining a positive hydrogen ion. And the last type we're going to look at is a weak acid with a strong base. Now, since this is a weak acid, we write it in its solution. Remember, all this is an aqueous solution. We write it like this because it doesn't ionize very well. It predominantly exists in its molecular form because it's a weak electrolyte. It just doesn't ionize very well. The sodium hydroxide, however, is a strong base, so it's going to show up like that. This does lose some hydrogens, not a lot, but they do give up some hydrogens, and they combine with the hydroxide to make water, and what's left over are the sodium ions and the acetate ions. That's soluble in water too. So take a look at the spectators. I think you can see the spectators of the sodiums, and that's it. Everything else kind of changes. So a weak acid plus the hydroxide ion goes to water, and then the anion of the weak acid. So for example, if the weak acid was hydrofluoric, we got a strong base, we get water, and the fluoride ion. So in summary, if we're writing NIEs for these things, strong acids, no matter what it is, shows up as the hydrogen ion. Strong bases in the NIE, no matter what it is, shows up as the OH minus. So you're probably, well, so what's the deal with the HCl then? What's the deal with the NaOH? These will always be spectators, okay? Weak acids, we just write them in their molecular form because they don't ionize very well. Hydrofluoric is written like that. Acetic is written like that. Weak bases, that should say, they're expressed in their molecular form. So that's NH3. Okay, it's just you write it like that. If it's, here's another weak base, methylamine. It's just written like that. So weak bases and weak acids are written however their formula is. All right, let's do these three examples. Let's go ahead and write the NIE. Nitric acid, that's a strong acid. Therefore, we write H+. Ammonia, that's a weak base. Therefore, we write its formula as it is, NH3. What's going to happen? The NH3 is going to bond with the hydrogen ion, and we get NH4, but now it's positively charged. Down here, potassium hydroxide, that's a strong base, so it shows up as OH minus. Perchloric acid is a strong acid, so it shows up as H+. So there's the NIE, that's water. And then down here, hydrofluoric acid, that's a weak acid, so we write the formula. Barium hydroxide, though, is a strong base, so we write OH minus. So we get water, and then what's left after that loses the hydrogen is F minus. All right, thanks for watching.